So here we have two Colnago C60 frames for review. So one of the things that often gets made in comments is, oh, you're only comparing one bike out of the thousands that are made, and that's a valid statement. However, a good quality system should produce repeatable products. So if outliers go through the system, then that's less than ideal as well. So but in this case, we've got two of the same model frames, and they should be pretty similar. So let's have a look and see how similar they actually are. So here are the serial numbers for both of these frames, and you know, on the last Colnago, not everyone, but people going, oh, it's a fake, it's a fake. You know, you're withholding information because you didn't put the serial number up. It's just like, it's not that big a deal. But if you're really concerned, here are the serial numbers. Check it out with Colnago, and yeah, we'll carry on with the review. So why did they come in, and why were they scrapped? So the one on the left had a significant damage to the top tube. Now, it wasn't a typical sort of crash. It's almost like it's been like run over just on the top tube, because there's no damage to other areas of the frame, and I don't have all the details of the crash. So that one came in through an insurance claim, and the bike was replaced. So I don't have access to what actually like the full details of the accident, and but there isn't any damage to other areas of the frame, only the top tube, and the top tube is significantly damaged, and that's why it was replaced. The one on the right had a crack indication, and you can make that out sort of through here, and the owner sanded through the paint to see if it was just a paint crack, and then basically decided, oh, he's going to get a new bike anyway. So that's why these have come in. So yes, you know, one's been involved in a crash, and the other one is basically a concern over a possible manufacturing flaw. So the weights as they were supplied, so the one on the left, you can see, is 1206 grams, and the one on the right is 1152 grams. Now the right hand one is a smaller frame, it is a smaller size, so we'd expect that to be a bit lighter. This is a frame on the outside, so you can see the top tube damage, but there's no indication of any damage on other areas on the frame, like the down tube or the seat tube or stays. They all look pretty straight and clean. The graphics, you have the carbon twill weave over the whole thing, and just the Colnago written on it with some airbrush decals and graphics and stuff like that. So yeah, pretty classic in the sense of Colnago. And here we have the inside. So first impression is it looks really clean. There isn't the sort of wrinkling that we've seen in some frames, or you know, other sort of, you know, gross sort of problems with lamination, you know, or bag left in there, or newspaper I've even seen in some bikes. So first impression, it looks pretty well made. So I mean, it is a tube and lug, so it's much easier to make good tubes and inspect them visually and before you put them into the bike. Because if you make a you know, what the bike industry call a monocoque, you know, with an internal bladder in sort of like a front triangle, you've got less opportunity to inspect, because it's effectively a closed structure. But with tubes and lugs, it's much more open, so you can inspect them more easily, and the manufacturing process is simpler as well. So it's more likely that you're going to get the tubes anyway are going to be good. So we normally start off with the bottom bracket area, and this one's no different. I've used a little a different background instead of the grey background for these close-up images. Well, it's yeah, let's see how we go with this other background. But overall, you look at that and you think that doesn't look too bad. And then you see down this area here, there's a void which is open to edge on the lug to tube bond, and that's less than ideal, because not so much from a strength point of view, because you've got so much bond area, because the lug sort of starts up here, so you've got all this bond area, so you've got and the adhesive will typically have a shear strength of, depending on what they use, but it'll be between 3,000 and 4,000 psi, so lots of strength there. However, the concern with that void is it's open to edge, so that gives a path for moisture and degradation of the adhesive, so that's less than ideal. So you ideally you want those bond interfaces to be sealed, so moisture and foreign object and all this sort of stuff can't get in there, and also being open to edge, it's more susceptible to peel, so that gap can open up because there's nothing holding it together. So that's less than ideal. There's also a little bit of void here, but we'll have a look at that in a future slide. The lug at the top of the tube, sort of in this area here, a little bit of wrinkling going on, you can see there. Bottom bracket is a machined aluminium threaded with their own sort of oversized threaded system, and that looks to be bonded in very well. There's no evidence of voids in that interface, and then there is a little a rivet you can see here, which looks like it just holds a serial number plate on, but it's a Bigfoot rivet, so you can see that I've just sort of drawn over it, but yeah, there's a lot of space, a lot of let's delete some of this stuff. Yeah, there's a lot of surface area on that rivet, so that's good. Let's go to the next one. Here we can see the adhesive spew out from the bottom bracket bond, so plenty of adhesive, big fillet, so yeah, that all looks pretty good. We can see the shell bonded in well. Nice compaction on the twill weave up through the down tube. You can see it's just the little bit of wrinkling, sort of, you can see that it goes sort of like that, and some porosity sort of in this area through here as well, so right in the root of that. So that could present itself as a crack in the lug at some point. So that's less than ideal. There has been a bit of moisture or water. You can see there's a little bit of dirt residue through here, and so yeah, that's sort of gone out through this drain hole, and then you've got the void right at that edge as well, so that's probably not that great. Moving along the down tube, or up the down tube, as I keep on saying in other videos, all that looks good. You can see through here there's it looks like an extra ply under the twill, probably some unidirectional to just provide a bit more strength and stiffness, etc., as per their design. A nice piece of glass in this area through here where the bidon inserts go to help insulate that and reduce any galvanic effects there. So that all looks pretty clean, and yeah, very good through there. And then to the head tube and down tube lower junction, the bottom headset cup is a machined aluminium insert, which is bonded in. The bond looks fantastic. There's no voids, and it's also got a lower lip. You can see through here, so which locates it'll locate the insert, but also improve the peel strength, and basically just enhance the whole that whole junction. So that's a nice feature. The lug itself, at the lower half, it looks good through here, but at the upper end you can see voids there and there. We'll have a look at those in a minute. Little bit of adhesive residue sort of through here, and indicating there's good adhesive. There's certainly aren't any voids along this junction here either. So overall that looks pretty good, apart from those big voids in the root. So let's have a closer look at that. So these voids, you can see that they're basically like there's a wrinkle. So the fibre is sort of kicked around like that, and so, and then even up here it's really going all over the place, and it's very wavy through here as well. So that's not that great, and this void through here, sort of right in the root. Now that's quite a high stress area, and so that's a bit of a concern. So this bike didn't have a crack in that area, but the white one, remember, it did crack through there. So when we get to that one, we'll have a look and see what's going on in that area on the other bike, which did show a crack indication through there. But it's in my experience that these lugs, we do see with the lugged Colnagos that they get these crack indications through the lugs sometimes, and if you're having voids like this and wrinkles, then that would certainly be a mechanism for those crack indications. So by having those wrinkles and that void, there's a significant loss of strength and mechanical properties through there. So yeah, so that's definitely a cross in the box of less than ideal. Then we move to the rest of the head tube, and the head tube itself looks okay. Again, the top bearing seat, again machined aluminium. So I'd imagine that they'd bond it in and then they'd line bore it as a secondary step after being bonded to ensure that the mating faces are nice and concentric, and you don't have any problems with your steering or headset wear or steerer tube wear. Often you see wear on the steerer tube, and that's often when the bearings aren't concentric, and so it puts an extra load basically on one face of the steerer tube, because the steerer is trying to be concentric, but if the bearings aren't, then you're going to have problems. So little bit of extra adhesive sort of spew out through here, but no voids through this lug junction through there. But that all looks pretty good. Now on the top tube, there was this sort of odd bit of a wrinkle you can see sort of going along here, and it's like a fold in the innermost fabric, and And so that's a bit of a concern. The whenever you have a wrinkle in the fiber, you basically have a discontinuity. So it's like a knot in a piece of wood, and it significantly affects the load path through that through that part of the structure. So there's definitely something going on with that wrinkle through there. So and it's a bit surprising because visually, when you'd inspect the tube, you'd be able to see that, particularly so close to the mitre end. So the tube has been mitered to the correct length, sort of through here. Yeah, you'd look in it and you'd see this ridge right in that area. So that's a bit of a concern that's gone through the quality system without being picked up. So the beauty with a tube and lug design is that if you come across a tube which you identify as being less than ideal, you can scrap the single tube and just get another tube, as opposed to a whole front triangle, for example, with a more of a monocoque type design. So why that tube wasn't replaced, yeah, that's a concern. So a bit of another cross in the less than ideal box with that one. So here's an overview of the top tube, and you can see that that sort of wrinkle that I was talking about in the previous slide sort of goes all the way to about here. The other thing of note is these lines here, 45 degrees, that's all delamination. So the tube is delaminated through the thickness, and that's how these structures absorb energy, and you basically get a delamination. What is interesting though is that on the top tube you've got a unidirectional inner layer, whereas on the down tube and the seat tube it's a twill woven fabric, which is a little bit more forgiving from an energy absorption sort of point of view. So because of the mechanical interlocking of the fibers, so a bit less likely to delaminate. In our experience, we see damage to the top tubes. That's sort of the main damage that we see on these bikes. We don't often see damage to other areas of the frame. It's mainly the top tube, and whether they're using a different, like their resin system is a bit. It's a non-toughened system, or whether it's a little bit resin rich or something like that, but it just seems that the top tube's are a little bit more susceptible to damage than the other tubes on the frame. So a little bit unusual with that. Moving to the lug at the seat and top tube junction. Again, there's lots of adhesive sort of through here, and that's good. There's you can see a little bit of a void in the lug through there, and some wrinkling sort of through here. But there's a big void through here, and a smaller one there, and then here as well. So yeah, again, the one down here, that's sort of probably, I mean, that's a large void, and it's just about open to edge. So doesn't seem to be much holding that lower edge together. So that's a bit of a concern with that one there. Here's another view, and yeah, you can really see that void. So it is just closed off right at the end here, so it's not fully open to edge. And then this one here has got just a filler of adhesive spew out. Otherwise it would be open to edge as well. So there are also, you can see some light sort of porosity and some filler in this area here. Um, yeah, so no voids to the seat stay bond, but quite substantial to the seat tube. Yeah, so that's not great. There is also some delamination. You can see these lines here of the unidirectional, um, and that's obviously from the mitering process where maybe the cutter wasn't sharp enough. It was maybe a little bit dull, and you get a little bit of fibre tear out in that space. Yeah. Going down the C-tube, and that looks good. So you can see that line here. So where the seat post fits sort of in here, that's sort of been ground to a uniform dimension, and so there's probably an extra ply in there, and then it's just they'll run a reamer through it and get the size spot on, so the seat post fits nicely. Yeah, the rest of the tube looks quite good. You've got a barrier, glass barrier ply where the front derailleur hanger sits, using these sort of nice Bigfoot rivets. The glass does just miss. You can see the glass ply ends there, and the rivet is sort of half on carbon, half on glass for both of that one and that one. So that's that it could be in a little bit better spot. They've got plenty of glass on this side, but there's nothing there. You can also see where the bottle inserts, there's sort of extra reinforcement, so you can see the laminate sort of gets thicker through here. And there's also glass. The glass, you've got a little bit of tear out through the glass, you can see there, also through there. So, but overall, that's sort of acceptable. Down to the chainstay bottom bracket junction. So when we did look at the bottom bracket, we saw that void there. So that's I mean, it's a reasonably sized void. Will it affect the overall strength significantly? Probably not, just because we've got so much bond area. It's nowhere near the edge, so it's pretty isolated. So it's not really that much of a concern, that one. That one will probably pass. The you can see the sticker, the C60 CS, which would be chainstay, 3K tilt R, which would be the right hand side. I'd say the 3K would be the external, because the internal's UD. There is a lug, sort of in the lug joint. There's a molding, sort of like a rib through that section there as well, to provide some increased support between the chainstays. So that's sort of a stiffening feature. And overall of the chainstay, a little bit of resin rich, sort of, you can see these lines through here where there's some resin pooling. Pretty minimal though, really. It sort of coincides with where the bag would necks down, so it goes from a larger section through here, and then sort of through here, sort of parallel sided again, but through that transition, that's where you're getting this problem. So just probably a little bit of wrinkling in the bag. That's not really a big deal. We do see a bit of delamination through here, which we'll have a closer look at. So here we have that delamination from, and you can also see some corrosion and some delamination sort of around here. So that's due to they have these little riv nuts in there, which then the cable guide screws onto that. So if you're running an electrical group set, you can take that, you can remove that. So you don't have this big cable guide sticking on the underside of your chainstay, but if you're running mechanical, then you obviously need that. So that there's some damage done during the drilling process. Now the other thing that's odd is that on every other insert throughout the bike there was a glass barrier applied, but in this location there wasn't, and you can see that sort of whitish residue is evidence of some galvanic corrosion, and yeah, and the delamination is from the drilling process. So they could take a little bit more care there, and I'm not sure why they didn't put the glass barrier ply like they've done really well in other areas of the bike. The dropout design it's an aluminium piece which is bonded in, and you don't see many issues with that at all. So the older ones, we used to see them, the bond used to break down over time. I've replaced or rebonded a few of them over the years, but the newer ones seem to be a bit better. They've got a barrier ply of glass, sort of in that interface area. So yeah, that's all pretty good. And then the seat stay, you're sort of moving up the seat stay. It's mostly good until you get to sort of this area here where the brake bridge is co-molded, and then there's a bit of a lack of compaction and a void through there. So you can see some wrinkling, a bit of sort of wrinkling through here, and also a bit of yeah, so I missed that more there. So a bit of a void and a bit of a void. So there. So that's just sort of indicating some that the compaction wasn't quite uniform through there. And here's the other side of that seat stay, so we can see the brake bridge, and so it's an insert, aluminium insert, which is then molded in with, got some filler around it. So all that looks pretty good. Unlikely to have any issues with that. And then here again you can see it's just some of the compaction variation, and particularly sort of this sort of area here, which looked like it didn't get really any compaction at all. It's when you can see the sort of the fibers almost look dry, it sort of indicates that you haven't had any pressure on there during the cure cycle to promote flow of the resin during cure. So yeah, that's not ideal. It's not a huge deal breaker though. And the other side of the chainstay, where we saw some delamination from the drilling, and also the galvanic corrosion, which is that white residue. A little bit of adhesive, sort of excess adhesive from when they bonded the drop add in as well, but it's more this galvanic corrosion. I don't understand why there's glass barrier plies in every other area except that area, and that's probably sees a lot more moisture because it's so close to the road, and road grime being kicked up, etc. So the only other thing to add was we have seen cases where these cable guide inserts, particularly on the top tube, and they're on the non-drive side on the top tube, that you get crack indications sort of right on the edge of the front, the forward and aft faces. And often we've seen cases where there's been insufficient adhesive in those inserts when they're bonded in, and hence you get a crack occurring because they're not really bonded in properly. So that's sort of the only other thing that we've seen on these frames over the years. So now let's have a look at the other one. So this was from the outside. You can see it's basically a lot of it, half of it's white. Again, sort of same sort of graphics, the classic sort of Colnago C60 with a bit of airbrush work, etc. A few little stripes and things, an Esto signature, and then the sort of top back end of the bike is the twill weave. So overall, sort of classic sort of Colnago look to it. And on the inside, once again, it looks, from external appearances, it looks pretty good. So nothing sort of jumping out. So it's very similar to the other one in that regard. Let's have a closer look. So bottom bracket, this one looks a little bit better in that it doesn't have the void down here, which the other one did. So that's no big void there. It still has a little void here, which we'll have a closer look at that in a bit further down the track. And it's also got sort of some dirt residue through here like the other one did, but the bottom bracket's bonded in well. A little bit of sort of wrinkling again sort of through these lug root, but very, very similar to the other one, marginally better in that it didn't have a void. And from this angle, a little bit less adhesive sort of spew out through here, but again, like there's no voids to speak of, so it's they've got the adhesive level about right. So that's all good. No problem there. You can see the sort of dirt residue going out the sort of drain hole there, and then the nice sort of twill weave. Again, that's all looking good. Up the down tube, same as before. You can see again that line, that extra sort of material thickness through there. You can see the glass barrier ply on this side. I cut on the other side of the fasteners of the rib nuts, so you can see that. All looks pretty good. So here we have the head tube and down tube junction, and as before, the bond to the headset cup through here is no issue with that, and down to the lug down here, it all looks good. There's lots of adhesive. There's lots of adhesive through here, no voids. But there was that crack in this area here, so let's have a closer look at that. So here we have the you can see the wrinkles, so the fibre sort of going like that. You've also got a bit of a void. So there's definitely something going on in this area with the the head tube lug, because the other one had similar wrinkles and a larger void. The other one didn't crack, which is a little bit unusual considering the extent of the floor, but it's from looking at both of these samples, you'd say that there's a higher probability that there's a problem with the production process in that region. It's twice as likely as if if I was only cutting up one bike. So I mean, I think you really need to do some more statistical analysis. Maybe, I don't know how many of these frames they made, but they probably made thousands of them, and it'd be interesting to cut up 100 of them. But I'm probably not going to do that in the short term. So let's just go with these two, that they both got damage in exactly the same, well, flaws, from manufacturing flaws in exactly the same spot of exactly the same type. So the rest of the head tube and the looking at the top tube, the if you recall, the other one had sort of quite a big sort of ridge wrinkle sort of in this area through here. This top tube doesn't have that, which is good. So I'm not sure how the other one got through quality. It would have been very, very easy to see visually when the tube was being mited. Yeah, that's sort of a bit of an unknown how that got through. That shouldn't have happened. And this one seems good though. So yeah, it's only a 50% chance of getting a defect. No, only joking. Closer look, headset cup bonded in well, lots of adhesive. This junction here looks good. Tiny little void sort of close to the edge there. Again, a little bit of void and wrinkling sort of through here. So, but it didn't propagate a crack through there. But you know, that void sort of in this area here is, it's close to the edge, and but it is pretty minimal, so I wouldn't be too concerned about that. Overall, the top tube, yeah, you can see sort of a little bit of fiber distortion, sort of, you can see all of the sort of down here, sort of, yeah, where the pressure's probably not quite even, a little bit of resin rich. As I said before, for some reason the top tubes seem to be a little bit more susceptible to damage than other tubes on the frame, so they could be a little bit resin rich, which would do that. It would be interesting to do like a resin burn off and to see what the fiber volume content is. If it is resin rich and it's not a toughened resin, then that would make the tube probably more susceptible to damage. Off to the lug where the seat tube and the top tube meet, and yeah, you can see a void through here, a little bit through here, but the one up at the top tube there, here, that's quite a large void. So, and it's right close to the edge, so that's less than ideal. The rest of it looks okay. Sort of, there's been plenty of adhesive sort of further through, a nice sort of fillet sort of through there, through there, a little bit of voids through there, but that's insignificant really. And you can see where the seat tube has been ground or reamed to a nice fit, to fit the seat post. But yeah, that void, that's less than ideal. And the other angle, so you can see where it's bladder molded, a little bit of a sort of bladder wrinkling through here, which extra bit of resin ridges and stuff. Not really a big deal. Little bit of, you can see through here and through there where there's just a bit less compaction like we saw on the other one. Porosity in this sort of region through here through that lug as well, but that's pretty minor. So yeah, again, very similar to the other one. Down the seat tube, and again looks almost identical to the other one. No issues. Yeah, we can see that the glass, there's sort of looks like it might be a little bit of an overlap of the glass barrier ply from the rivets. So around these nice sort of Bigfoot rivets, and then you've got the other glass barrier ply sort of going through here where the bidon inserts go, and so it looks like there's a little bit of a gap there, but where the rivets are, it's sort of been captured, so it's a little bit better than the other one. You can see the additional thickness of the laminate here, like the other one, but when they drilled, you can see the glass is delaminated sort of a bit further out than what the other one did. This one's sort of pretty similar to the previous frame, but yeah, here the bit more delamination. And here we have the chainstay to bottom bracket junction, and if you recall, there was a void in the other one in exactly that same spot there, so so they're consistent. And I did say that on the previous one that it's relatively minor because it's so far from the edge, and there's significant bond area there, so it's highly unlikely it's going to cause any problems with that. The rest of it's all pretty good, looks pretty similar to the other one, same sort of little sticker, a little bit further in the joint. The overall view looks pretty much the same as the other one, probably a little bit better. It doesn't have those resin wrinkles sort of in this area like the other one did. And then we've got that same drilling and delamination at the inserts. So here, on this one, I cut it on the other side of the inserts, so we can see how the inserts sit. And again, I'm perplexed why there's no barrier ply there when there's a barrier ply. You can see it here where the dropout's bonded in, and every other insert has got barrier ply. This one is delaminated and has corrosion in that area, so a little bit yeah, perplexing why they've done it so well on the other areas, and then they've left that area to itself. Dropout again, almost identical. There's plenty of adhesive, good bond, no issues with that. And then the seat stay, again we've got in this area here, it's a bit of a compaction issue, sort of again just below the brake bridge. Let's have a closer look. You can also see it here. So where it's sort of there's a change in sheen, that's just where there hasn't been any real compaction on the fibre through there, and so it's that area highlighted there, and also it's the same sort of thing going here. So it's right near where the brake bridge, yeah, it's just obviously moulded in one piece. And here you can see, so that's sort of the back end, so the other side of the cut piece, and you can clearly see that the wrinkling going on here, where the fiber's sort of going all the way around like that, when ideally you'd want the fiber just going across like that. Also some porosity sort of in the root, and then porosity. It looks like some sort of syntactic filler through here, and you can see there's porosity in that. So not the cleanest area, but again unlikely that that's going to be causing any significant problems in the long term. I mean, you could get a crack indication popping up through that over time, just because of that wrinkle. So that's sort of typically what causes these crack indication. These, what people call paint cracks. There's no such thing as just a paint crack. It's usually there's either a ply step or a wrinkle underneath. That's what's usually going on. So that's two of the same model of frame cut up, and from what we saw, that the floors were pretty much the same type of floor, same location on both frames. So they were consistent. So now they just need to be consistently good in those areas, as opposed to have flaws in those areas. So the particularly that the wrinkle and the void at the head tube lug, that's probably the biggest concern, because even if it hasn't got a huge effect structurally on the bike, and you need to do some actual destructive testing to validate how much of an influence it has on the structural properties of the bike. Regardless of that, nobody wants a big crack right around their head tube down tube junction. Nobody wants to be looking at that when they're riding their bike down a hill at 80 kilometers an hour or 50 mile an hour, or whatever you want to do. You don't want to see a big crack like that. So that is a concern. Overall, the frames, typically, I mean, they're a little bit heavier than a lot of the other frames, like the monocoques, like a specialized tarmac or whatever, or Trekking Monda, Giant TCR, like all those frames, probably close to 300 grams lighter for the same size frame. So what that gives you is, it does give you more margin for error, and the a bit more of a safety buffer. So there's probably less chance of one of these Colnago frames failing catastrophically, because it's just got more material in it. So it's a 1200 gram frame. So which is sort of funny in itself, in that all the marketing will do of sub-kilo one frame. So I'm not talking about Colnago necessarily. They've sort of resisted that race to the bottom a bit, but many of the other brands will come up with this belief that if a frame is over a kilo, it's a heavy frame. But there's still a lot of frames which are very desirable that are well over that weight. So don't be too hung up on weight, but having a big crack across your head tube down tube junction is a concern. So they need to do a little bit better on that, in my opinion. The main tubes generally were made well, well compacted. There was that issue with the top tube, which, as I touched on, I'm not sure why that got through quality. So yeah, it would be interesting to see like a check sheet when they bond and when they assemble these bikes, like what they actually check for in their quality process, because there's some things which I think they should have picked up on and they didn't. So anyway, we'll leave it at that. Put any comments you have down below, and we'll see you again soon. Okay, bye.